Sutton here, bringing you the IM3 Honors 4-2 Extra Practice number 5 solutions on completing the square. There's a puzzle that goes along with this one that we're going to check out now. So here's the puzzle that goes with this extra practice. The idea here is we've got 20 different equations that we're supposed to solve, and they're telling us that one equation has no solution at all, and then they want us to transfer that word into the block that has the answer. So for example, if we solve question 1 and we find that the answer to that is this 6 negative 3, then we would put the word 2 down here. Now that's not actually the answer, but that's the idea. Now there is one other thing about this puzzle. Since I already did the whole thing and know what it should come out to, I do happen to know that this plus or minus 2 radical 3 is incorrect. This should actually be a 3 radical 5, 3 radical 5. So just keep that in mind as you go, and I'm going to change that on my screen just to have it corrected from here on out. All right, so let's do it. Here we go with problem number 1, and note that I've made the change down here in my grid, so this answer is now plus or minus 3 radical 5 instead of 2 radical 3, and I'll just carry that through the whole way. Now our strategy on all of these is eventually going to be to square root both sides of the equation. But we can only do that when we have the x squared all by itself and a constant on the other side. In this case, we already have that done for us. So I can just square root both sides, and I get x on the left, square root of x squared. And then on all of these, we also have to remember when we square root an equation, we get a plus or minus that's not included in the square root. So this is going to be plus or minus 9, plus or minus the square root of 81. And plus or minus 9, that's going to be over here on the right side, so that's going to be the word 2 over there. For problem number 2, we have our squared term all by itself, so we can go straight to square rooting both sides. So we have a equals plus or minus the square root of 20, but now 20 can actually be split up into the perfect square 4 times 5, so plus or minus radical 4 times radical 5. I have to do this to match one of the answers, this whole radical simplifying business. So that's plus or minus 2 radical 5. And I see that up here on the top, so we're putting was right there. For this problem, I have 3n squared, not n squared on the left side. So to get the squared term by itself, I have to first divide by 3, giving me 15 over on the right side. Now I can square root both sides. So we have n equals plus or minus the square root of 15. 15 doesn't have any perfect square factors, so that means that this is as good as it gets in terms of simplifying. And if I look for this answer down below, I see plus or minus 15 right down here at the bottom in the center, so I'm putting in down there. For number 4, I've got a coefficient on my x squared term that's not 1, so I have to get rid of that before I can square root. 84 divided by this 7 here, that's going to give me 12. And if I square root both sides now to get x by itself, the square root of 12, before I do that, I actually can split that up into 4 and 3, 4 being a perfect square. So plus or minus radical 4 times radical 3, which gives me plus or minus 2 radical 3. And plus or minus 2 radical 3, that answer is going to be, where is that answer? I know it's here, right there, right on the left side. So that's who right there. To do this next one, before I can square root that v squared, I need to first divide by the 2. So 180 over 2 gives me 90. And then square rooting both sides, we have the square root of 90. I can actually split that up into square root of 9 times square root of 10. So this will then be plus or minus 3 radical 10. 3 radical 10 is over here on the right side, so that's the word but. To solve this next equation, I'm going to begin by adding that 49 over to the right side, so I have the y squared all by itself. And now I'll have plus or minus square root of 49 plus or minus 7. So plus or minus 7, that's right over here on the left, so that's make. To solve number 7, let me first start by adding 16 to the other side. So we have x squared equals 24. 24 is not a perfect square, but if I square root both sides and get x equals plus or minus that square root, I can actually split that up into 4 and 6. So I'm going to have then plus or minus, let's see, square root of 4 is 2, so plus or minus 2 radical 6. And that is going to be up here toward the top, so there's once. For this next one, let me begin by subtracting 11 from both sides. So we have b squared equals 75. And now if I square root both sides to get b, the square root of 75, I can break that up into 25 and 3. So I'm going to have plus or minus 5 radical 3, which is right here about in the middle. So we'll put 10 right there. For number 9, things are starting to get a little bit more complex. In order to get x squared by itself, I have to undo two things now. First, I have to add this 3 over there, so that's 18 on the right side. Then I have to divide by 2, so that's 9. But now this actually isn't so bad. X squared equals 9, so that's just going to be x equals plus or minus square root of that, so 3. And plus or minus 3, that's down here in the lower corner, so that's no down there. For this one, I have to subtract 8 before I can do anything else, so that's 50 on the right side. Divide both sides by 5 now, we have w squared equals 10. And then if I square root that, w is going to be plus or minus radical 10. Radical 10 can't be split up at all. It's one of my answers. It's right here toward the top, so that's the word A. For this one, number 11, I'm going to start by adding 200 over to the right side, so that's 180 over there. And now I'll divide by 4. 180 over 4, I believe that's 45. And now I can square root to get x. Plus or minus, now 45, I can split that up into 9 and 5. 9 is a perfect square. So we have plus or minus the square root of 9, which is 3, and then the radical 5. And that's that one that was incorrect on the original puzzle, right down there that I changed so that everything worked out. So that's going to be the word the going right there. For number 12, I'll start by subtracting 18 from both sides. 4 minus 18 is negative 14, which is kind of interesting. Then if I divide that by 7, I've got negative 2 over there. And then if I square root both sides, we have y equals plus or minus the square root of negative 2. Now this is really interesting. If you are a little more advanced in your mathematical studies, you might understand that the square root of a negative, you have to take out an I, because I is the square root of negative 1. So this would be plus or minus I radical 2, if you wanted to write a complex answer. However, none of these answers have i's in them. They didn't expect you to know about imaginary numbers. They did expect you to know that there is no real solution to the square root of a negative number, because no matter what you square, you can't get a negative by multiplying a number by itself. So this is going to be this no solution box right here. That's where there is going. Here we are on number 13, and the problems are becoming more interesting still. Now we have a squared parentheses equaling a number. Now in terms of solving techniques, the squared parentheses is kind of like a big X that you can square root. So we're going to square root both sides to start this thing off. On the left side, that'll give me just x minus 1. On the right side, I'm going to have plus or minus the square root of 9, so plus or minus 3. And now to get x truly by itself, I have to add 1 over to the right side. Now typically when I do this with one of these plus or minuses, the number that I move over there, I put to the left of the plus or minus. That's just the convention for doing this. So we have 1 plus 3, which is 4, and then 1 minus 3 is another version of this, so that's going to be negative 2. So we have to actually keep both of those answers. And that's going to give us 4, negative 2 right here. That's going to be laugh. For this next one, we're going to treat this just like we did number 13, as in square rooting both sides. So on the left, I've got just a plus 3, no square. On the right, I have plus or minus the square root of 25, plus or minus 5. To get a by itself, we subtract 3 from both sides, so we'll move that over. And then I have to write out my two answers. Negative 3 plus 5 is positive 2, and negative 3 minus 5 is negative 8. Looking down for 2 and negative 8, I see that right here, so that's going to be a told right there. Next up, on number 15, I'll begin this one by square rooting both sides. So we've got t minus 4 on the left side. On the right side, I've got plus or minus square root of 7, which cannot be simplified any further, so I'm just going to leave that the way it is. And then I just have to add 4 over the right side to get t by itself. So 4 plus or minus 7, that's in the lower right corner, so that's did down there. For number 16, things are getting a little bit trickier on this one. I'm going to start just like the last two problems by square rooting both sides to unsquare this parentheses. So we have x minus 2 on the left. On the right, I've got plus or minus the square root of 28. But now 28 can actually be simplified a little bit more. I can break that up into 4 and 7, so plus or minus radical 4 times radical 7. And I'm going to do two things on my next step. First thing I'm going to do is I'm going to add 2 over to the right side so that I have x all by itself, so x equals 2, plus or minus, now let me actually square root this, so plus or minus 2 radical 7. And that's going to match up with the answer that I see, let's see here, where is that? Right here in the middle. So that's going to be students right there. Only a few blanks left. We've almost solved this puzzle. Here's number 17. Now we just saw the word students, so it's not a shocker that the word teacher factors into this puzzle somewhere. So on this one, before I can square root, I have to divide both sides by 3. Otherwise, I'm going to catch that inside the square root, which is not going to be fun. So 12 over 3 gives me a 4 on the right side. And now that I've got the squared stuff by itself, I can square root both sides. So that gives me x minus 5 on the left, and the square root of 4 plus or minus 2 over on the right. I'm going to add 5 to get the x by itself. So I end up with two answers, 5 plus 2, which is 7, and then 5 minus 2 gives me the other answer of 3. 7 and 3 is in the upper right corner here, so that's going to be teacher. Number 18 is a lot like number 17, so we can first, before I can get rid of that square, I need to divide both sides by 5. 40 over 5 gives me an 8 over there. Now I'll square root both sides. So we have n plus 1 equals, now it can get split up into 4 and 2, so plus or minus radical 4 times radical 2. Let me subtract this one to get it over to the right side, so n is by itself, so we have negative 1. Plus or minus, this is going to be 2 radical 2. And I see all of that craziness down at the bottom in the right area here. So that's going to be a 10 down there. For this one, I can go straight to square rooting since I don't have the squared stuff with anything else attached to it. So square rooting the left, I've got just 2x minus 3. Square rooting the right, I have plus or minus 9, the square root of 81. Now I can add 3 to both sides and divide both sides by 2. But I have to go a little bit further to match an answer choice. 3 plus 9 over 2 is 12 over 2 is 6. 3 minus 9 is negative 6. Divided by 2 is negative 3. So I have 6 and negative 3. That's where my jokes are going. Now for the very last problem, the word pun, I think we know where that's going because there's only one blank left. But let's just do out the math here. So square rooting both sides, we have 4t plus 1 on the left. Square root of 49 is 7 on the right side, plus or minus that. To get t by itself, I have to subtract 1, so negative 1 plus or minus 7. And then I have to divide by 4, so all that stuff over there over 4. So I need to actually simplify this to get my two different answers. Negative 1 plus 7 is 6, and 6 over 4 can be reduced to 3 over 2. And then for the other branch, negative 1 minus 7 is negative 8. Negative 8 divided by 4 is negative 2. So that indeed matches up with our last blank there, so we're putting pun right there. And now at this point I've got all the things filled out, so let me solve the puzzle, or at least make sure it makes sense. There once was a teacher who told 10 jokes to make the students laugh, but no pun intended. Oh, that's interesting, because I guess they were all puns, so none of those jokes made them laugh, but pun intended, that's like a phrase, whatever. I think you get it. Maybe you're not laughing either. In either case, Mr. Sutton signing off.